Supposing we need to make a 1 to 10 gear reduction. The smallest we really want any gear to be is about 7 teeth. So we can make that a 7 to 70, which is a bit unwieldy. So we'd be better off making this as 2 stages, and 10 can be factored in as 2 times 5. So we can make a 1 to 2 reduction and a 1 to 5 reduction, and that would give us the 1 to 10. But let's suppose we want those two ratios to be a little bit more close to the same ratio. So we could start with a 1 to 3 reduction, and then we need a 3 to 10 reduction to get our 1 to 10. And we could multiply this by 7 to 21, and this one here, we multiply that by 3, gives us 9 to 30. So that would work quite nicely, and we have a total of 67 teeth for those. But let's suppose we want a gear ratio that's a bit more even than that. Let's write our 7 to 70, and let's imagine between the little wee gear we have another gear and then the bigger gear. The gear ratio for those three is still going to be the same, except that the final gear rotates in the opposite direction. So 7 to 20 to 70. We can write that as 7 to 20 and 20 to 70. Trying to reduce those a bit, we don't want to go smaller than 7 on here, but the 20 to 70, we could write that as 2 to 7, and then let's see, multiply that by 4, that gives us 8 to 28. So our 1 to 10 is equal to a 720 plus a 8 to 28 reduction, and that gives us a total of 63 teeth for these ones, whereas the 70 to 77 was 84 teeth. And having a more even gear ratio, we have 63 teeth versus this other try where we had 67 teeth. Let's try another example. Suppose we want a 1 to 12 reduction for a clock to go from the minute hand to the hour hand. So we could write that as multiplying both sides by 8, we'd have 8 to 96. Now if we want to divide that into two separate gear ratios, and we want those ratios to be about the same, we want the gear ratio to be roughly the root of 12 for each set of gears, and that is equal to about 3.464. So 8 times 3.464 is 27.7, so we have 8 to 27.7, and of course we can't make 27.7, so let's say we make that one 8 to 28, and then we need a 28 to 96. We can divide the right side by 4, and that gives us 7 to 24. So we went down below 8, but this works out really nicely because the next one up would be much bigger. So basically we need an 8 to 28 gear reduction and a 7 to 24 gear reduction. It doesn't always work so nicely. Sometimes you have to pick an intermediate value that is something else. So if 28 hadn't worked out, I would have tried 26, 27, 28, 29, and see whatever divides nicely. Now for a clock, the hours hand and the minute hand have to be concentric. So our gears here and then another set of gears here, like so, they have to have exactly the same shaft spacing, that is between the two centers of the shafts. Now if both sets of gears use the same size teeth, the shaft spacing does not end up the same. And to adjust for that, we can use my gear generator program, and I'm just going to enter a value of 8 centimeters for the shaft spacing, and the program automatically recalculates the size of the teeth to get that shaft spacing. The two sets of gears came out to almost the same size, but slightly different tooth counts. One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Exactly where we started. Well, here's what could be a clock face. The hands move in the correct motion with each other.